Warning: engineering content. Few minutes of engineering. Artificial supplementary cementitious materials, treated calcined materials. Artificial pozzolans can be classified into two main groups: industrial byproducts and treated calcined materials. Treated calcined materials are man-made pozzolans, in which they're exposed to high temperatures and then ground, thereby modifying their chemical and/or physical structure, in order to enhance the pozzolanic activity. This category includes materials such as rice husk ash, calcined clays, burnt shale, metakaolin, burnt organic matter, municipal solid waste ash, waste glass, and others. Rice husk ash. It is a byproduct of rice paddy milling industries. Rice husk, an agricultural waste produced during paddy milling, is used as a fuel in the rice milling process, which in turn produces rice husk ash. Rice husk ash is mainly composed of amorphous silica, thereby being highly pozzolanic. Its chemical composition may vary depending on the treatment, such as the burning temperature, however silicon dioxide remains the primary component. The typical chemical composition of rice husk ash is as follows, where silicon dioxide is the main compound with a content about 87% by weight. Rice husk ash is known to reduce the heat of hydration and the permeability, and enhance the resistance against chloride and sulfate attacks in concrete. Burnt clay or shale. Calcined clay, burnt shale, and metakaolin are produced by regulated burning of natural minerals at temperatures between 500 and 800 degrees Celsius. Metakaolin is originated from pure natural kaolinite clay, and is used in concrete at lower dosages than calcined clay or burnt shale. These materials are mainly composed of silicon and aluminum oxides. Burned organic matter. It is a treated artificial pozzolanic material produced by controlled burning of agricultural residues. The burning process decomposes the organic carbon and increases the concentration of silicates, which produces a highly pozzolanic material. Burned organic matter residues usually have a high water demand due to their high specific surface area and rough surface texture. Municipal solid waste ash. It is produced by the incineration process of municipal solid wastes. The two main byproducts of incineration are bottom ash and fly ash. These ashes have a very complex chemical composition when compared to coal ashes. Municipal solid waste ash is usually composed of silicon, aluminum, and sulfur oxides, in addition to high concentration of metals such as mercury, lead, arsenic, zinc, cadmium, and others having high concentration of soluble salts. Thereby, a proper treatment is necessary before its application in the concrete industry. Waste glass. The primary raw material used in the manufacturing of glass is sand. Sand, which is mainly composed of silica, is heated till it turns into liquid sand, at about 1700 degrees Celsius, and then allowed to be cooled down and shaped. During this process, liquid sand undergoes microstructural transformations, and never returns back into a solid form even after cooling down. Instead, it becomes a frozen liquid, also known as amorphous solid. Some materials are usually added to liquid sand in order to alter some properties or change the color of the final product. Waste glass is usually used in concrete in various forms and compositions. The non-recyclable glass waste is treated, cleaned, crushed, and/or ground, before its incorporation in concrete. Waste glass can be used in the form of a coarse aggregate, fine aggregate, and supplementary cementitious material. Generally, coarse waste glass decreases strength and may cause the undesired alkali-silica reaction. Finer waste glass, in the form of fine aggregates, seems more promising, however the maximum particle size of glass and the quantity used should be taken into consideration in order to limit the alkali-silica reaction. Whereas, the use of glass in the form of powder can actually mitigate alkali-silica reactions in the presence of reactive aggregates. Glass powder is considered pozzolanic when used as a supplementary cementitious material in the proper particle size, usually less than 75 micrometers. It is mainly composed of amorphous silica despite its various types produced, such as silicate, soda lime, borosilicate, lead, and aluminosilicate glass.